Hello everyone, thank you for coming. We are the Student Evaluation Analysis Toolkit, and it is a preemptive student performance assessment. Our team consists of myself, Brian Ng, our team leader, Brian Hughes, and our mentor is Dr. Eric Chow, over there. So let's start talking about the motivation of our project. So professors strive to help students reach their highest potential, which leaves them constantly worrying about how the student is doing in class. iLearn is able to track their current grades, but lacks anything in terms of predictive analysis. And that's where we come in. For the duration of this 117 spring semester, we worked with Dr. Eric Tao in order to try and predict this performance. With this prediction, professors will be able to lend a helping hand early on to students if necessary. And to achieve this, we had to ask ourselves two questions. The first of which is, can we even predict student performance? And if we can, what kinds of trends are important? To answer these two questions, we first went about data cleaning, which would sanitize the student data so it would protect their privacy. Next came data integration, where we added useful information such as aggregate data to the student data to better visualize what we're working with. Next came what's possibly the most important step in our project, data selection, where we did extensive research as to what sorts of features are important and what we can use for our project. Once we had those features selected, we prepared the data by transforming it in order to prepare it for the pattern evaluation, where we use things like linear regression in order to get results as to if we can predict the student data. Once we have those results, we presented it in the forms of graphs and plots in order to visualize it better. Because of the simplicity of our project, all of this was able to be done in our studio.
So were we successful with our goal? Well, sort of. As we look more into the data mining process, we begin to reevaluate the scope of our project. In other words, if our initial goal is to shoot for the moon, we first have to build a rocket first. However, when we first got the initial data, we had some complications such as private information that needed to be removed before we could have access to it. However, with the help of our mentor, we were able to move forward with the project and start processing the data in a form that could be run into our models. After several iterations, we were able to create a file that would pre-process the data from the raw iLearn data and automate and associated documentation. With the documentation, we were able to create a launchpad for future projects and can provide meaningful analysis on iLearn data, but also provide some data exploration as well as some assessments of the models we created. Although we can't show all the data to you, we have some data explorations here for one of the classes. On the left, we have a box plot that showed the whole semester of Class A we had in 6 weeks time period. On the right, we have the total number of logins for the same class for the first half of the semester, but it's divided out into the days of the week, with Sunday being on the left-hand side. However, to continue our work, we would need more data collected from specifically student data as well as student demographic data. We'd also need to pre-process the data because of different features we would be incorporating in our project. Future research is required for the different models we would be creating, which incorporate different class structures. And once we get those models, we would start doing the seat and iLearn integration. We'd like to acknowledge our mentor, Dr. Tao, for providing support for our project and guidance, and also providing the sanitized iLearn data. We'd also like to thank Dr. Brunt for his teachings, guidance, and support. If there are any questions about our project, we will be happy to answer them during the poster session. Thank you.